operations with complex numbers. I warned you guys yesterday this is what we were doing today, so here we go. Imaginary numbers. You know how we're always talking about all real? Well, guess what? This is why. Because we do have imaginaries. I is defined by the square root of -1. Okay, we know negatives underneath the square root are illegal, and this is why, but we can still do it on a different number set. So, if I equals the square root of -1, I squared equals -1. If r is a positive real number, then the square root of -r equals I times the square root of r. So the negative goes away and it becomes an I out here. Okay. Also, if you have I times the square root of r and you square it, well, it's going to be I squared times the square root of r squared, which is -1 times r, which is -r. So we're going to use that to do some simplifying and some solving. First of all, simplify. Okay. This is going to become, the negative becomes an I and the square root of 3. And we usually put the I first because I don't want to get confused with the I being underneath the radical. So this next one would be I square root of 16, but what is the square root of 16? Oh, 4. So this would be 4i. Solving. If we're solving by finding square roots, we need to get the x squared by itself. In order to do that, we subtract 11. Okay, so 2x squared equals 48, negative. Divide by 2. X squared equals -24. Take the square root. Okay, so x equals, now we're solving, so we still have the plus or minus. The negative is going to come out, that's going to be I times the square root of 24. Now 24 has a perfect square factor, so we have to keep simplifying. 24 is equal to the square root of 4 times 6. Don't forget my I in there. So this is equal to 2i plus or minus 2i times the square root of 6. Let's solve another one. Here we have 3x squared minus 7 equals -31. Add 7. So 3x squared equals 24 again. -24. Divide by 3. X squared equals -8. Square root. Once you get the squared part by itself, you square root. This is going to be x equals plus or minus. Make that a positive. Write yourself an I. Square root of 8. Well, the square root of 8 is 2 times the square root of 2. So this is plus or minus 2i square root of 2. Complex numbers. In standard form, we have a complex number of a plus bi, where a is the real part and bi is the imaginary part. Anytime you have, actually all numbers are considered to be complex. They either have an imaginary part or not. So the ones that do not have an imaginary part are real numbers. The complex numbers that do have the bi part are just complex numbers. If there's no real part, it's said to be a pure imaginary number. So these numbers are pure imaginary. There is no real part. There's no a plus or minus whatever. Okay, we can add, subtract, multiply, and divide complex numbers. So that's what we're doing. Okay, adding and subtracting. This is just like combining like terms. You've got the imaginary parts that you're going to combine and the real parts that you're going to combine. With addition, you can just forget about the parentheses and combine like terms. 9 plus -6, which is 3. I plus 7i is going to be positive 6i. And you leave it like that. With subtraction, you have to be much more careful. You're going to do the same thing. 3 minus 8, well, that's negative 5. 7i minus negative 2i. Minus a negative becomes plus. So 7i plus 2i is 9i. Okay. If you need to, make this a plus sign, make that a negative, and distribute. Distributing the negative sign. Okay, multiplication. Here I've got I times 9 minus I. You're going to distribute. So you're going to do I times 9, that's 9I, minus I times I, which is I squared. What does I squared equal? Oh yeah, it equals negative 1. 9I minus negative 1 becomes plus the positive 1. And the final answer, written in standard form, is 1 plus 9i. The next one, these are binomials, so we multiply them like we multiply binomials. We use the FOIL method. So the first is 3 times 5, which is 15. Your outers are going to be 3 times negative I, so it's going to be negative 3i. Your inners, 5 times I, so plus 5i. And your last is going to be negative I squared. Okay. Well, if you want, negative I squared is always going to turn into plus 1. Okay, we can do that. So 15 plus 1 is 16. Then negative 3i plus 5i is positive 2i. Here's the real part. Here's the imaginary part. Complex numbers. Division. Okay. When we divide, what we're going to do in reality is we are going to multiply by the conjugate pair, because all complex numbers have a conjugate pair, and all we change is what's in here. Okay. So the conjugate pair, it's just like when we're simplifying radicals. We're going to multiply by 3 plus 2i, 3 plus 2i, and we do the FOIL method. Okay, so the numerator is going to be 5 times 3, which is 15. So 15. Your outers, 5 times 2, so 10i. Your inners, 6i. And your last, 2 times 2 is 4. I times I is I squared. So this is going to be plus 4i squared. But what does that I squared do? I squared goes away because it's 1 and it makes it negative. So this is plus negative 4. So 15 plus negative 4 is 11. 10 plus 6i is plus 16i. Now we're going to do the denominator. This one, the inners and the outers are going to cancel each other out. Because look at outers, 6, it's going to be 6i minus 6i. The i's are gone. So we take 3 times 3, which is 9. Negative 2i times positive 2i is negative 4i squared. But what does the I squared do? Goes away, makes it a positive. Looky there. It's no longer imaginary in the denominator. It's just like rationalizing. So we've got 11 plus 16i all over 13. Okay, next thing, graphing. We can graph complex numbers. We have to graph them in the complex plane, which means instead of having x and y, we have real and imaginary. This is the complex plane. So what we do is we go to the real part this is A plus BI. This is the real part. So we go to negative 3 on the horizontal, and then we go to negative 4i on the vertical. And we plot that point. That point is negative 3 minus 4i. Okay, so imaginary and real. The real is the horizontal. Imaginary is the vertical. Now, the last thing we can do is find the absolute value. Finding the absolute value of a complex number. We've got this formula, and to do this we forget about the I, and we're just going to deal with A and B. And we're going to find it by doing the square root of A squared plus B squared. So, if our example is find the absolute value of 4 plus 3i, okay, we want to find the absolute value. We use the formula. It's going to be the square root of 4 squared plus 3 squared, which is the square root of 16 plus 9, square root of 25, which is 5. Okay. How is this absolute value determined? Well, the absolute value is actually defined as the distance from the origin on the complex plane. So if this is A, this is BI, we're essentially doing the Pythagorean theorem. A squared plus B squared equals C squared. Okay, that's how they get this. This is the length of the hypotenuse, so that's where that comes from.